evening and welcome to First Say Chats by Dr. G. I'm Dr. Adana Grandison, a physician in Barbados and your hostess for this evening. This evening, we will also be joined by Mr. David Ellis as my co host, who will be joining me shortly. First Say Chats by Dr. G is a live podcast that provides listeners with a unique opportunity to not only hear complicated medical conditions explained, but also clarify any misunderstandings you may have about that condition. After all, a medically aware and educated patient is an empowered patient. And this evening, our episode is entitled To Vaccinate or Not to Vaccinate. And our guest is Dr. Wilmore Webley. Dr. Webley is an associate professor of microbiology and the director of the pre-med and pre-health advising at the University of Massachusetts Amherst. Webley was born in Dry Hill District, Bellis Gates, in St. Catherine, Jamaica, and was the first in his family to attend high school and college. He completed a Bachelor's of Science degree in Medical Technology at Northern Caribbean University. Webley earned the master's degree and PhD in microbiology at the University of Massachusetts Amherst, with expertise in immunology, infectious disease, host pathogen interaction, and a concentration in vaccine development. Dr. Webley is a Fulbright Scholar, a recipient of the Manning Prize for Excellence in Teaching, the Distinguished Teaching Award in recognition for outstanding teaching accomplishments, a recipient of the Black Student Union Award for outstanding devotion and dedication to the profession, and a Commonwealth Honors College Faculty Lecture Series awardee. He serves the UMass community in various capacities, including as faculty senator and a member of the University Health Council. He also serves on the editorial boards of the International Journal of Vaccines and Immunization, Vaccines, the Journal of Medical Microbiology and Diagnosis, and Microbiology and Experimentation. He is a member of the International Society of Vaccines, the American Society for Microbiology, and the Chlamydia Basic Research Society. Good evening and welcome, Dr. Webley, and welcome, Mr. David Ellis.
Good evening, Dr. Granson. Thank you so much for having me.
I am just going to wait a few seconds so that we can get Mr. Ellis on the line. I'm seeing that he's trying to connect.
Good evening.
Good evening. So, Dr. Webley, we're here this evening and we wanted to get this conversation started. Really, I'm getting a lot of feedback. Really around, let's start. Really, what is the role of the immune system? Let's start there because we tend to get a better understanding of vaccines if we could understand how the immune system works.
Yes. So when you think about the immune system, what you really want to be reflecting on is that here is a system that is not confined to any organ of your body. In fact, it doesn't have a specific organ. It is designed to work with all of the organs, all of the tissues of your body, because they need its protection. So if you think about it as being your security force for Barbados, you have your army, which luckily doesn't have to do much because you're not under constant attack. But let's assume that on every shore of your island, you had people every single day trying to get in to destroy you and your way of life. You have an arm of the immune system called the innate immune system that is designed to protect you at those borders. And in fact, your skin actually makes up an important part of that integument that helps to keep microbes at bay. Very few microbes can actually penetrate the skin. Also, you produce certain oils on your skin, and that actually has immune enzymes in there, some certain types of enzymes that are able to kill bacteria. You have points that are soft targets. You have points that are easily breached, your mouth, your nostrils. And every single day, you inhale thousands of viruses and bacteria into your nostrils. And at those sites, you have parts of the immune system that actually sample those cells that make up the immune system, sample those areas and ask a fundamental question: is this friend or foe? Because not every microbe is a pathogen. In fact, just less than 1% of the microorganisms that we know actually cause disease. The vast majority of them don't. So the immune system, therefore, is designed to protect you from any entity, whether it's an infectious microbe, it's a protein that is foreign that might come into the body and cause disease or cause harm.
Okay, and how does the vaccine, any vaccine, work in terms of helping that immune system to fight that organism?
So I mentioned briefly that there's the innate arm of the immune system, and the innate arm of the immune system is what works immediately. Its job is to protect you from anything that comes at you immediately. But you have what is called an adaptive arm of the immune system, and that is the part that protects us from the vast majority of diseases, including viruses and intracellular pathogens. The issue is that the adaptive arm of the immune system doesn't kick in fully until about 2 weeks after you have encountered the microbe. And you might ask yourself, why? Why would it wait so long? Because you see, your innate immune system is designed to take care of the vast majority of what you encounter. And this is important. The only reason we get disease is because the immune system gets overwhelmed, either because the load, the total number of microbes that have entered the immune system is just outrageous, or that the microbe has a capacity to divide rapidly and destroy immune cells, that the individual has a compromised immune system because of autoimmune disease or other types of, maybe they're a transplant patient and they're on immunosuppressive therapy. But you only get disease when the immune system is overwhelmed. And so, with that in mind, your innate immune system is your first responder. That's like you in the US, we call 911. I'm not sure what your number is in Barbados.
511 and 911, yes.
511, 911. Something happens, you call 511, 911. That's your innate immune system. You don't want to have an intruder coming in your house, and when you dial 511, your special forces or your army deploys a whole barracks to your neighborhood, right? You want your local police right there to respond, right? That is the issue with the innate versus the adaptive immune system. The adaptive immune system is the army. It comes in when the innate immune system has failed to clean up, and it comes in hard. That is why when you have a cold, for example, or even with getting these vaccines, after the second dose, for example, the second day, you feel awful because it drains your strength. Why? Because this adaptive arm of the immune system has kicked in. But as I said, it takes about 2 weeks before it is fully in place. Now, that is okay for several microbes that the innate immune system is going to clean up. But let's say you have a rapidly dividing microbe like COVID, like measles, like mumps, like the influenza. That microbe has the probability to kill you before that 2 week period. So if you have never been exposed to this microbe before, if you've never seen it before, if your immune system hasn't developed a memory of it before, the way a vaccine works is that the vaccine comes in, and vaccine is like you're sending a message, like you're sending an email to the body saying, hey, look out for this thing. It could come and affect you. So you send an alert to the body. The body now knows that it is supposed to make a response against it. And it still takes that 2 week period to give what is called a primary response. And what took 2 weeks to develop, if you ever see that microbe now, it takes 2 days for you to clear it. So what took 2 weeks before is now high in a week and a half to two, in a day and a half to 2 days. Why? Because the immune system has developed a memory of what it saw. The immune system is very versatile. Anything that it has seen, it has a memory of. You have memory cells. It's like a database that you've put it in. And as these microbes pass through the airport security,
Hello, Dr. Webley. I think we just lost you. Go ahead as you pass through the airport security.
I think we've lost them for
I,
quite a
I,
while.
I think we lost him for a quick second there. Just going to wait for him to come in. He's still showing in the room.
because if you did, every single microbe that you
Dr.
encounter, you
Dr.
would be in
Webley,
bed.
Dr.
Yes.
Webley, we lost you from the airport security. Just take us back from there.
My point was, sorry about that. My point was that when you get this initial response
Right,
to any microbe, whether it's naturally or you get a vaccine, we call that the primary immune response,
right.
right? It takes approximately 2 weeks in the average person to come up. However, once you've seen that microbe and those 2 weeks have passed, your memory cells now have this thing in its database. And as I was saying, it's like you're passing through Homeland Security, whether it's at the arm or the leg or the fingers, wherever this microbe comes in, it's going to come to the draining lymph nodes and it will encounter cells that have that microbe in its database. And that microbe is going to be recognized. And what took 2 weeks now takes a day for you to launch a really strong response, not just a shorter time to the response, but a much higher response to this entity. And that is why scientists figured out a long time ago, in 1796, Edward Jenner figured out that if you actually prime the immune system, let it know that it should expect this microbe, it's able to prepare for it because you now get past that primary immune response that has to take about 2 weeks. And now you're ready and primed and waiting for this specific microbe. And as I was saying, it doesn't matter if you're a vegetarian. It doesn't matter how well you eat. It doesn't matter how fit you are. It doesn't matter what you're doing physiologically, biologically. This is the way the system works. You cannot bypass that primary immune response. And you can have a memory to something you never saw,
Right.
essentially. And that is why vaccines work. Vaccines give the immune system a memory under safe conditions.
Okay. Mr. Ellis, would you
Yes.
like to start off with our first vaccine question this evening?
Yes. Well, Dr. Webley and Dr. Grandison, first of all, thank you for having me on the podcast. We are in a period of vaccine hesitancy. And one of the biggest questions I have heard from others is this: what it would have taken 10 years to develop a vaccine, we have been able to rush it. And we've been able to rush it in circumstances where even the American Food and Drug Administration has not necessarily given a final approval, but has given emergency approval. In those circumstances, people are very skeptical. They say, I need more time to be able to assess this thing. How do you respond to those people?
Thank you so much for that question. You're very right. These are the type of things that would cause hesitancy in anybody. The question that the person asking should really turn around and ask themselves is, why in the past did vaccine development take so long? What made it take 5 years and 10 years and even longer to bring a vaccine to approval? Because that is the correct question to ask. You see, many people believe that this 5-year, 10-year period is a prescribed period of time for vaccine development, but there's no such thing. There's no minimum time that you should take to develop a vaccine. So vaccines in the past took a long time to develop for several reasons. The technologies we're using is number one. So for example, I've been working on trying to develop a chlamydia vaccine for many, many years now. And every phase of it, from the preclinical phase, which is the animal stage, we go through tissue culture, growing the microbe in the lab. All of those things take a tremendous amount of time. Also, as a researcher, I have limited amounts of money to use to put into the vaccine development. So I can't move from stage 1 to stage 2 of the process unless I've definitively proven that stage 1 has worked, and try now to write up for and get more money, get more investors, in other words, to give more money for the next phase, right? In other words, you have to stay at phase 1 and convince people that this thing is good before you can get monies to go to phase 2, before you can get money to go to phase 3. And vaccine development is extremely expensive. The third thing is, when you're doing vaccine development, especially when you get into the second and third phases, it requires a lot of people to be infected. So for example, let's say I was going to make a vaccine for chlamydia. What I would have to do, once I have a product that I think is good, I would have to go out in the community and find a cross section of the population that I think are people who are more likely to get infected with chlamydia. And I'm required to go and tell them to be careful, but I'm hoping that they're not, because I want them to get infected with chlamydia. If they don't, I can't prove that my vaccine works. All right, let's put that over now into COVID. Why did were these vaccines develop so quickly? Number one is the platform. The mRNA platform, which by the way is not a new platform. This platform has been in development for over 20 years. It just hadn't had an approved vaccine. They were phase 2, phase 1 clinical trials that they got approved to go through, which is in humans. They got approved to go through these clinical trials. They didn't have a product to bring to market. So this mRNA technology is very simple. All that the researchers needed was the sequence of the virus. Once they got the sequence of SARS-CoV-2, they were able to sit at a computer and look at the genetic sequence that make the spike proteins. They have known since 2003 that the spike proteins are very important for the entry of SARS-CoV of SARS viruses into human beings. And so once they got the sequence, it took literally 3 months before they were able to develop this vaccine and get it into phase 1 clinical trial, because they just needed to get some bacteria to make the sequence, put it in, and have our cells make it. In typical fashion, if I was doing that for a protein vaccine, it would take months upon months upon months of high production to even get a small amount enough to put into somebody. The second thing is that they never had to worry about money. They got dumped with federal money, money from investors, money from countries that were trying to secure these vaccines. And what they started to do is that the moment they saw that the vaccine was safe in phase 1 and phase 2, they overlapped phase 1 and phase 2. So before phase 1 was complete, they got approval to go to phase 2. Before phase 2 was completed, they got approval to go into phase 3. And phase 3 is where you do what is called a case control study, where you have people who get the placebo, some saline injection, and you have people who get the vaccine. But here's what was happening at that time. The pandemic was raging. We were having in the US over 300,000 cases a day. So what would typically take months upon months upon months for you to get 100 or 200 people in a clinical trial infected, it took just a month to get that same amount or triple. Moreover, they started manufacturing the vaccine in phase 3 clinical trial, right? So the moment they started phase 3 clinical trial, before they even got data on it, they started manufacturing the vaccine in a normal vaccine development system. Nobody would do that. No investor would allow their company and what they had invested in to go into manufacturing before they had full FDA approval to make that vaccine. But there was always this thing called emergency use authorization in place. In other words, if you have an ambulance that's just driving on the street and it's not taking anybody, it doesn't need to put on its sirens. It doesn't need to be blaring, and it doesn't need to be driving and going through the lights. However, there's a contingency in place that if there's an emergency, you do not want that ambulance sitting in traffic, in rush hour traffic, waiting for the light to change, because the person on the other end who they made the call for could die by the time you get there. So there was always that provision. And so what they did is that they turned on the sirens. And for emergency use authorization, it means that the FDA goes ahead and they're constantly evaluating at every stage so that they can look at the data even while it is still going through. There are 40,000 people in these phase 3 clinical trials. Once they got data for 200, 300, 400 people, they can start analyzing that data and asking, did the vaccine work? Is it safe? Are people dying from it? Are people getting sick from it? What are the side effects? And as they evaluated that, they waited 2 months after the first data came out to show that it worked. And then they asked for emergency use authorization. It was just in place. The same process that is typically used to evaluate vaccine efficacy and safety was used in this EUA process. So they didn't get a pass.
Right. And I'm glad that you brought that up, Dr. Webley, because one would easily think that maybe the data can't be trusted because they went from phase 1 to phase 2 to phase 3 before, as you said, it was completed. But it's because the information, the data that was being collected was being constantly evaluated every single step of the way. So you could see the trends, you could see if it was actually working. And because you had such a huge population that could get infected, that you could test against, certainly you would be able to make a clinical decision. Is that what I'm understanding that you're saying?
Absolutely. And remember that the vaccine company is not the one who evaluates the data. A data monitoring board is hired just to do that, right? So the vaccine company doesn't know which patient got placebo and which one of them got the vaccine. They don't get to see the data until the data monitoring board actually unmasks the data and send that to the vaccine company. So there's a degree of separation from the vaccine company and the clinical trial that's mandated by the FDA. That's why you must do, so that you can remove the bias. But that's how these vaccines were developed. The truth is that one of the major things that happened is that the technology had been worked out so well before. You know, I've been teaching about this for about 10 to 15 years now. Nucleic acid vaccine platform. So it's something that they had been working on for a long time. They had some kinks in there. They worked them out, and they were lucky enough not to have any major safety issues as they were going through this process, because that is what sets clinical trials back. You have to go back to scratch, you know, if there's a major safety issue. And right now, you go and you look, there are 5 vaccines that have been abandoned. That 5 COVID vaccines that were abandoned during clinical trials because they had issues. Right. So it's not like it's a system where you're allowing everybody to go through. You're clearly evaluating everything. And for the first time, the public was able to see the same data that the FDA board was seeing.
So Dr. Webley, I want to jump in here because you spoke about the mRNA vaccine platform, but here in Barbados, we have access to 2 vaccines. Well, initially it was AstraZeneca vaccine, and now we have the Sinopharm vaccine, the viral vector being AstraZeneca and the inactivated being Sinopharm. Can you really explain, are these vaccines safe? They have met WHO emergency use authorization. Is this the same type of board that is used to evaluate them? I know, for instance, they have the SAGES group, certainly, who look at these vaccines, which is the Strategic Advisory Group of Experts on Immunization.
Yeah.
But really run us through how these vaccines are created, especially the ones we have here on the island, because persons have so many questions, especially about the Sinopharm vaccine. I think we've heard a lot about AstraZeneca, but really explain to us how does the Sinopharm vaccine work?
Yeah, the Sinopharm vaccine goes right back to the way original vaccines were created. It's an inactivated coronavirus vaccine. So essentially, what they did is that they actually went ahead and grew up the coronavirus, grew up SARS-CoV-2 in large numbers, and then they used a chemical to kill it that binds into its DNA and kills it. So this is a killed vaccine. And then they go ahead, they purify it out of the solution. They measure the total amount in there and they inject that in you. So when that is injected, your immune cells seize it and they see the whole virus, except that the virus is replication incompetent. It's not dividing, it's not alive. And so the immune system gets to look at all of its proteins and it gets broken down into its individual component protein, because that's how the immune system sees molecules. It doesn't see a virus as one molecule. It sees it at thousands and thousands and thousands of small pieces. In other words, the immune system doesn't go to the buffet and take up its food and just eat it. You have to take it and cut it up into discrete pieces and feed it to it, and it has to recognize all of that. And so that's how that vaccine actually works. It's a pretty simple technology, pretty simple platform that we've had vaccines like that before. So this is not a new platform. There's nothing sophisticated about it. It has, it's come out of China. It's 2 doses, 3 weeks apart, injected into your muscle. And the data shows that it has a 78.1% efficacy, which is a decent efficacy for any vaccine. By WHO standards, anything that's over 50% effective, it would get approval, right? And so the good thing about it is that from the data coming out now, it seems that it is able to prevent hospitalization and death in individuals who have, for example, the Alpha variant. The data on the Delta variant against this Sinopharm vaccine has not come out yet. They're in the process of doing that work right now. But that data has not come out yet. But I expect that even if you don't have full protection, you'll still have pretty decent protection against pretty all of the major variants of concern right now with the Sinopharm vaccine.
May I ask a question on this
Sure.
score?
Yeah, absolutely.
Sure.
Because how satisfied are you with the kind of peer review that this particular vaccine has had versus the others, and the whole process? One of the difficulties is that, based upon various things that have happened with things out of China, there is an undercurrent of mistrust. And
Yeah.
therefore, people need to be made more confident that all the necessary steps have been taken, no shortcuts, and that those of you who are in the scientific community can be confident with the process that you have been told has been followed.
Yeah, and so that's a very good question, and it's always the concern. I was one of those people who said early last year, until I see the data, I'm not taking any of these vaccines. Because number one, it was being politicized here in the United States. You were having a race to see who could finish a vaccine first. People were trying to corner the market, especially the Russians. And so I was very, very concerned, because you don't want a medical product to be under this type of pressure. But from all that I've seen, from all the publications that I've seen coming out on the Sinopharm vaccine, it's a legitimate vaccine. It is safe. Killed vaccines are typically very safe. The only concern there is to make sure that they do very good quality checks, which they seem at all the different parts of the process to have very good quality checks, ensuring that their killing process is actually working. And so they have to go back and try to see if they can grow the virus for different batches. If it grows, they know it wasn't killed, and you can't send that batch out to anybody. That's the risk you run with doing a killed vaccine, that if your killing process for whatever doesn't work, then you're giving somebody a live virus instead of a killed one. But there are easy ways to test that, and they seem to have a very good system to do that. And while Sinopharm is made by a Chinese company, they have other investors. The Beijing Institute of Biological Products, which is state-owned company of Sinopharm, they have other people who are looking at that technology and evaluating at every step. So I'm as confident as anyone can be with anything that comes out of China. And yes, you're right that they've been cagey about a lot of things. But as a product like this, you would imagine that they wouldn't want their names to be dragged through the mud of doing something bad. And so every company that is making these vaccines is trying in good faith to make sure that these vaccines are safe and effective. And now with the competition of other vaccines out there, they even more so have to make sure that these vaccines are safe and effective. So in my
And that's
opinion,
why that's where
yes,
the
go
question
ahead.
of peer review that's where the question of peer review would be important as well, because one official here in Barbados actually said that in their judgment it was not as peer reviewed as the other vaccines. So that is one of the elements that could give people a sense of confidence or less confidence.
Yeah, I mean, to say that it wasn't as peer reviewed, it might not have been talked about as much. But every time these vaccines come out, they're very much peer reviewed. Remember that this vaccine is not only approved in China; it's been approved by the UAE, where part of the clinical trials actually took place.
The UAE.
Yeah, the Arab Emirates.
Yes, but I
And
saw,
and
with all due respects, I saw information only today from Reuters that said that the UAE did use Sinopharm, and in June they had to go to Pfizer for boosters because Sinopharm was not as effective as they thought it should have been. I saw that
they,
today from Reuters.
they were measuring efficacy based on whether or not people could get infected. And I've always said, as an immunologist, that's not how you want to measure the effectiveness of a vaccine. Vaccines were never designed to prevent infections. Vaccines were designed to prevent disease. There's a difference, right? And so what they were measuring, and I did see the wranglings about that. They're not talking about the ability of the vaccine to prevent hospitalization and death. They're talking about the ability of the vaccine to prevent infection. What they haven't emphasized is that the people who actually got infected did not end up with severe disease and death. And that is the way you have to measure the effectiveness of a vaccine. Because you see, look at the mRNA vaccines, for example, with 90 something percent efficacy. People still get infected with the virus after getting 2 doses of those vaccines. Now, those people typically don't have symptoms, or the symptoms are mild, and that is a rare event that you do get infected. But what people have to understand is that none of these vaccines has the ability to completely prevent you from getting infected. There's no such product ever on any market. And so that is important. Now, is the Sinopharm vaccine as good as the AstraZeneca? No, the data shows that it's not as good as the AstraZeneca. It's just the nature of how the vaccine is made. You're showing the immune system an entire viral particle, and it is there making a response to every single area of that viral particle. What these other vaccines, like the AstraZeneca vaccine, has done, the AstraZeneca vaccine has taken a single protein and shown tons of that to the immune system and say, focus on this protein, the spike protein, which is what the virus uses to enter. Not all the proteins on the virus are important for entry. And if you're going to stop a virus from causing infection, you have to stop it from entering. And that is what these other vaccines have as an advantage, I think, over the Sinopharm vaccine, because the immune system is not necessarily giving priority to the spike protein. And I think that is why it has a little bit lower efficacy compared to some of these other vaccines that have shown the immune system a single protein.
Right.
Thank you.
Dr. Webley, we have heard some persons bandying around the fact that the virus within the Sinopharm vaccine was inactivated by formaldehyde, which a lot of persons know is one of the carcinogenic chemicals that we have out there that essentially prepares dead bodies. I've actually even seen it here in the group. But can you just clarify? Because we know that that is not the case. We know that we actually have a different chemical that is used, which is the beta propionolactone. So can you just really
Exactly.
clarify what is the difference there, so that we don't have any confusion where persons are thinking, oh, they're trying to give us formaldehyde to kill us all?
Yeah, I mean that formaldehyde used to be used way back in the day to inactivate vaccines, and I think people are just reminiscing on that. Formaldehyde hasn't been used in vaccines in ages, and you're very much right. The beta propionolactone has been used, and what it does is that it inactivates genes, and when the genes are inactivated, the virus dies.
Right.
Right. So it intercalates into the viral genome, and that's how it causes killing action. In addition, because the viruses are inactivated, they're dead, they're not going to replicate. They actually had to add an adjuvant to the vaccine. So, in addition to having the viruses in there, you actually have an aluminum based adjuvant. And an adjuvant is designed to actually enhance the immune response. It aggravates the immune system and calls in more immune cells. When those immune cells comes in, they see the inactivated coronaviruses and respond to them by degrading them.
Okay.
But
So
when they're thinking about, for example, the inactivated polio vaccine, Jonas Salk's initial vaccine in the 1950s were based on this technology, and they used formaldehyde at that time. So I think people are just going back. But hepatitis A virus is a vaccine, is an inactivated vaccine. The rabies vaccine is an inactivated vaccine, and they're not using formaldehyde in those.
right. Now, we know that the conversation of recent really has gone to variants. And I just want to stray away from
Mm-hmm.
vaccines for one quick second, because there's something known as vaccine escape as a result of the variants. And we've
Right.
seen lots of breakthrough cases recently, even in the vaccinated patient.
Yeah.
For instance, I saw a recent study that came out of Massachusetts, where about 74% of the persons totally infected were vaccinated. But only 4 of those persons ended up being hospitalized. And that was a study with approximately 6,500 people, right? And then, CDC has actually done lots of research about this whole thing of breakthrough vaccines. And one thing that they were able to very clearly show is that those persons, and I'm glad that you brought up the point earlier, that persons who are vaccinated do not develop disease. They can get infected, but they don't develop disease, because they were able to demonstrate that essentially 4 out of every 100,000 persons that were fully vaccinated ended up with hospitalization. And a
Mm-hmm.
further 1 out of every 100,000 persons died, right? So I wanted for you to, first of all, talk to us about the Delta variant, because I know there's lots of buzz about that, but then really explain why something like variants on a whole can potentially cause vaccine escape, and what is the danger.
Yeah. That was always the concern from the moment this pandemic started, the development of variants. Anytime you have a virus that has been allowed to spread as widely as this SARS-CoV-2, you're going to get variants, right? We see them all the time in all sorts of virus families. HIV develop variants all the time, especially these RNA viruses. And all that a variant is that as these viruses divide, every time they get into a new person and divide, which is all they want to do, there is a probability that they're going to make a mistake in their DNA, in copying their DNA, their RNA material, their nucleic acid material. The vast majority of times, that mistake is detrimental to the virus. In other words, it makes the virus weaker, viruses die. But every now and then, based on the immune pressure that the virus is under, it is being killed, it's being taken out by the immune system. It develops a variant that is better than the one before. And any variant that develops that is better than the original strain that it came from is going to become dominant, right? It's either that it's more infectious, it's more contagious, It can stay out longer in the environment without dying. Yeah. It binds tighter to the receptors that the virus used to enter. Any one of those scenarios make that variant a variant of concern. And so, we remember the alpha variant, which was the B117 that came out of the UK, and it was about 50 times, 50% more contagious than the original strain. This Delta variant appears to be even more transmissible. Mm-hmm. In fact, where you would typically have one viral particle over a period of time in the throat of somebody who has the alpha variant, with the Delta variant, you would have 1,000. Which means that the probability of somebody around you getting the virus when you cough or speak is significantly increased. So the Delta variant, for those who have experience with chickenpox, remember how contagious chickenpox is. The Delta variant is now at the place where it is as contagious as the chickenpox, where every one person who gets infected could actually infect between 7 to 8 people with this virus. So it now puts you at a place where even people who have been vaccinated, because the viral load in the throat and in the nostrils of the infected people are so high, individuals who have been vaccinated can themselves get infected. Now, as you said rightly, most of those infected people probably don't even know that they got infected. I mean, I'm in a situation where at my university, I get tested every week, even though I'm vaccinated. It's just something that we do. We have a big testing center. And if there ever is an infection in somebody who is vaccinated, they go and sequence it because they want to see if it's the Delta variant. That's how we know how widespread the Delta variant is. But what it means, what they found out, you talked about this outbreak in Massachusetts, just down the road. I live in Massachusetts, just 2 hours away from where I live. And in Provincetown, where this outbreak took place, 74% of the people in that outbreak were vaccinated, which means that if you have vaccinated people in close proximity, which they were, right, having parties, being together in close proximity, if you're going to a movie or a show and people are coughing, you're going to get infected with it. And what they found out is that the vast majority of vaccinated people didn't become sick. What we're seeing here in the United States today and other places in the world is that the pandemic we're having now is a pandemic of unvaccinated people. 99.95% of all infections that led to death over the past month was unvaccinated people. And that's just telling. When you look at the states like my state that has over 70% of people vaccinated, our rate of infection, even with that outbreak, our rate of infections are extremely low. Right. Compared to places like Minnesota and down in the South where people are unvaccinated. And that is the case now for all of the Caribbean and all of Africa, where vaccines have not been made available at the level that people would get vaccinated at the level that would even offer simple amounts of protection, which means that with these variants, and it's just a matter of time before Delta variant shows up everywhere. And with that, you really are going to have to wear your mask. You're going to have to distance. You're going to have to make sure you avoid crowds. You're going to have to make sure you go back and wash your hands often and just be aware of who is around you. Right now, when I go into a crowded place, I wear my mask.
Okay. I wanted to ask a question as it relates to something that we have been hearing a lot of persons on our side of the world speaking about. And I have a question here from one of our listeners. Are natural cures recommended in treating or preventing COVID-19 disease versus taking the vaccine?
I'm not sure what natural cures are, but there's nothing out there that has been proven to work against SARS-CoV-2.
Right.
If you're asking me, is there some tree out there in some forest near you that might have some chemical in there that could potentially kill this virus? There is a probability that that is true, but nobody's found it yet.
Right.
Nobody knows what that is. Most antivirals that they've tried against this virus haven't worked very well. And, so when you say natural treatments, I'm not exactly sure what to make of that,
Right.
because it would suggest that there is something you can do naturally, washing yourself, or drinking some type of tea, or some bush from down Mass Joe's farm, and that's gonna prevent you from getting infected with COVID. Listen, nothing, not even these vaccines, are good at preventing you from getting infected, right? And so
Dr.
one
Webley?
has to be very, very careful about that. Yes, sir. Yes.
Yeah, I'm curious about this question of the transmissibility of Delta and
Mm-hmm.
its implications for how much of a distance we keep. There are times when we have been told 3 feet. Other times we've told 6 feet. We're told at points you can have no more than 50 people in a place, or 10 people at a funeral, and all of that. I even masking. To what extent is the heightened transmissibility of Delta causing us possibly to rethink some of the protections and the protocols that we have had before?
Yeah, I think we have to rethink all of it. We certainly have to rethink all of it. The 6 feet distance is a good one, and the reason for that is that viruses do not get into the air on their own.
Right.
Viruses aerate in micro droplets and in larger droplets, right? So when they get out of your throat, out of your mouth, you don't have a single viral particle getting out and getting into somebody's throat or nose. What you have is a micro droplet with multiple viral particles trapped in it. So I don't know if you've ever seen somebody come off an airplane in the cold weather, and you start seeing like that steam coming out of their mouth as they breathe. Those are micro droplets, right? And if the larger droplets will fall right in front of you when you're speaking, or when you cough, or you sneeze. The larger the droplets, the closer to you they fall. If you have a mask on, those droplets are trapped when they're coming out of your mouth and your nostrils, right? And so it's not that the mask can trap a single viral particle. That's not what the mask is doing. What the mask is doing is that it's trapping these, you can see them as little air bubbles with viral particles trapped inside of them, and is able to stop them. So for me, I still maintain a 6 feet distance when I can. And if you're outdoors, of course, you don't have to worry as much, because if you cough or you sneeze, the breeze that is blowing, there is a larger area for the virus to actually dissipate. So even if it gets to you, it gets there in a smaller concentration, as
But
opposed to being in a closed room.
a poor quality mask, though, may well leave you vulnerable.
It could, and it depends too. If you have a reasonable quality mask in an outdoor setting, you're going to be okay for the most parts. If you have a mask that's not fitting properly, what I see as a poor quality mask is a mask that just doesn't fit properly. It leaves pockets around your face, and that now literally can serve as a trap for those particles, and you inhale them as they come down the sides, and get in. Your most vulnerable place is going to be in a room, in a building with poor ventilation. That's going to be your most vulnerable place, because every time, even if you have a single person in there that's infected, every time they breathe, those droplets go into the air, and we know that micro droplets can hang for a while in the air, and they accumulate over time. And as you inhale, you have the potential to actually get those. But the virus is more transmissible, not because it's gained some magical quality, but it's because it is so much more replication competent. In other words, it comes in greater numbers as it comes towards you to infect you. That's what makes it more transmissible. But it's not more deadly. We haven't seen it being more deadly than the original strain.
Right. Dr. Webley, we have another question here from the message board. There are persons who think that if you keep your immune system strong and boost it up, you will not catch COVID. How true is that?
It's completely false.
Right.
The virus doesn't infect you because something is wrong with you. The virus infects you because it evolved to utilize a protein that we have on almost every organ in our bodies called ACE2, this angiotensin converting enzyme receptor. And that is why we get infected with it. So, yes, you can boost your immune system, but when people say to me, you boost your immune system, I immediately know that they've never studied immunology.
Right.
I immediately know that. Because if you've studied immunology, you realize that the vast majority of people, even those you might think are not in great health, actually have a pretty decent immune system. What people need to be in is in good health. You could have a good functioning immune system and you sabotage it because you're stressed out. You could have an immune system with all the cells you need that can function totally fine, but you sabotage it by not sleeping as much as you should, by not exercising, by not being joyful and not having a good life all around. So it's really overall health. And if you're eating right, if you're eating a balanced diet, you don't need to take supplements. And I know that these supplement companies that pop up everywhere would like you to think that you need to live on supplements. But the truth is, you don't need to buy supplements if what you're eating has enough zinc in it. If you're going outside and getting some vitamin D, if you're eating a balanced diet, then you don't need to add supplements to your diet. The truth is, no research has ever shown that adding these supplements actually help your immune system. So, do you need a boost to your immune system? Most people don't know the answer to that because they've never had a full profile of their immune system done. It's an expensive thing to do. You have to look at the different cell types. And if you have certain types of diseases, if you're a person with an autoimmune disease, boosting your immune system is the last thing you want to do.
Right.
It could be detrimental to you. So I always hear people say this, but the truth is that no, you don't need to boost your immune system. You need to have a good functioning immune system where you have a balanced life. Almost everything you do impacts your immune system. Most people don't realize that a major part of your immune system is in your gut.
Right. Absolutely.
You have a whole microbiome there that senses what you eat. And we know that it changes based on what you eat and what you take into your system, the amount of toxins that you have and all of these things. All of that is affects your immune system. So I would say if you have a good functioning immune system, keep it up. Get in a little exercise, drink plenty of water, try to live right with people, try not to be stressed out, get a good sleep at night. All of that, it do wonders for your immune system.
Someone has raised the question here of ivermectin. This has been coming up quite a bit. What are your thoughts on that?
Yeah, ivermectin is this anti-parasitic drug that has been around for a long time. The manufacturers have made it cheap so that because, parasites, of course, affect the vulnerable in populations, people in low socioeconomic situations in countries that don't have a lot of resources. And so ivermectin is this drug that have been around. A few studies have shown that ivermectin appear to have antiviral qualities. And so people, rightly so, asked whether or not ivermectin could have any effect against this virus. A researcher went ahead and did a study where he used 60 times the highest dose that is approved for human use in tissue culture. In other words, he grew some cells in a dish in a lab and put 60 times the amount of ivermectin on it that would be okay for a human being to use, and saw that there was a reduction in the viral load. And he put that paper on the pre-reviewed database, preprint database. And everybody jumped on that bandwagon and said, oh, ivermectin can cure SARS-CoV-2. And I say to people, well, let's wait and see what the clinical trials have shown.
Right.
Now we've gone through the process of multiple clinical trials from all over the place, and all of them have shown that ivermectin does not have an effect, a positive effect in preventing disease symptoms and reducing hospitalization or anything to do with SARS-CoV-2. But what has happened is a lot of the anti-vax people in the anti-vax movement have jumped onto this and say, hey, the government doesn't want you to know that ivermectin works. They're keeping it away from you. And if you're used to believing a conspiracy theory, it's probably an easy thing to believe. But I've said I'm not writing off ivermectin as a treatment for SARS-CoV-2. I just haven't seen the studies where it has worked. When
Right.
somebody has a study where it has worked and shown definitively in a clinical trial to work effectively against SARS-CoV-2, then I would say, yes, bring ivermectin in as a therapeutic. But ivermectin would never replace a vaccine. Because what a vaccine does is that a vaccine helps to protect you prior to you being exposed to the virus. What ivermectin is going to be used for is that you're going to get it when you end up in the hospital. Right. And so I know that in India, they kind of gave out ivermectin in different communities, and the data has come back now and shown that it just didn't work. So they stopped doing it. And so it was the same thing with hydrochloroquine and a few other drugs that didn't get as much airplay. But the consensus right now in ivermectin is that we just haven't seen a clinical trial where it has worked.
Okay, Dr. Webley, we have here currently on the island about 30% of our adult population haven't been vaccinated. And we know that we have, according to the surveys done back in, I think, 2016, 2017, that we have close to 1/3 of our population being a pediatric under 18 group.
Mm-hmm.
Here on the island right now, AstraZeneca and Sinopharm really have not been approved for children, right?
Yeah.
What are your thoughts as it relates to the importance of having a community, especially a group like healthcare workers or essential workers at the very least, taking the vaccine, given the fact that we want to reduce the chances of one, having persons who may present with disease go on to having severe disease and hospitalization and or death. And then certainly the possibility, given that we are a travel hub, uh,
Hmm.
potentially developing a variant that we cannot control.
Yeah. It's a very important question. And that is true for the vast majority of countries that have signed up with COVAX, to get vaccines. I think the best thing that one can do is that the people who can get the vaccine need to get the vaccine. And that's why it's so unfortunate that so much anti-vax sentiments have been put on these vaccines. And so many, I don't mind people asking questions. What has been disheartening is to see the falsehood that is rapidly spread about these vaccines, because it has caused more vaccine hesitancy than I've ever seen anywhere at any time. And what
Right.
this means is that it's going to take you longer to have the protections in your communities that you need. Um, if every person who could get a vaccine would get the vaccine when it's available, then your children would be more protected. Your children who can't get vaccinated yet would be protected. And yes, they're doing clinical trials for the AstraZeneca vaccine to see what dosage work, which kids, and what is safe. So sooner or later, they're going to come out with a kids version of AstraZeneca. But at the same time, what has to happen now is, because there's so many people who are not vaccinated, you're going to have to continue wearing your mask. And even if you're a vaccinated person, you're a parent who is vaccinated, and every adult in your household is vaccinated. But if you have children who have not been vaccinated, you still need to wear your mask when you go into a crowded places, so that you don't get the virus, which might not cause disease in you, but you could now transmit it to your kids. Or if you have elderly people in the home who haven't been vaccinated, having your kids out there not wearing masks, going into situations where they're not distancing, they're going to bring that virus back home at some point. Now,
Right.
to be honest, the numbers in Barbados are not terrible at this point in time. Whatever has happened, whatever you've done, in general, you've done a good job at keeping the numbers low. That might not always be the case. And especially with these more contagious variants, that might not always be the case. And so people have to continue, not be afraid to live your lives, but live your lives within reason, being cautious, being thoughtful. Getting a vaccine at this point in time is probably the best gift you could give to your neighbor who can't get vaccinated.
Right.
It is probably the kindest thing you could do to a vulnerable person who is probably an organ transplant patient, who we know that even with these vaccines, they're not fully protected, are not even protected at the level that other people are. For somebody who has immunocompromised because they've undergone chemotherapy for cancer and they're trying to recover. Those individuals are highly vulnerable, and the probability of death from this virus is very high. People who've had diabetes and high blood pressure in your communities, if for whatever reason they can't get the vaccine, they're at very high risk. So for people who can get the vaccine, search out the information. When you hear stuff, ask questions, talk with your doctors, talk with people who actually know about vaccines and vaccine development, talk with people who actually understand the science. If all you're going to are platforms and people who agree with you, you'll never learn anything new. You will actually just be more stuck in your ways. And what we're seeing here now, Dr. Grandison, is we're seeing almost every night on the news, we're seeing people who had these anti-vax sentiments and then end up getting COVID. And right at the point when they're going to be intubated in the hospital, they ask if they can get the vaccine now.
Right.
Or when they can barely breathe, you can barely hear the words. They say to you, "I'm so sorry, I didn't believe and I didn't take the vaccine." It's a sad thing.
I must confess, though, that it looks as though the media in the United States is on such a campaign to get people vaccinated that it is looking for cases like this to highlight. But anyhow, there's this person asking
that might be true. That might be true,
it looks that way.
But you also have on the other side, on Fox News, you'll never see that. So you have two sides of the two extremes of the media in the country.
Yes,
where
correct.
You have people who are saying that, and if these cases weren't happening, you wouldn't be able to see them, right? And of course, the media doesn't see all of these that happen either. But you're seeing it more and more now, especially because the states that had the most people, the areas that had the most people who were resistant to the vaccine, are the areas now that have the highest cases of the virus. So you're seeing those cases more and more now because of that as well. And you might have areas in Barbados that would have herd immunity and other areas not. It all depends on vaccine uptake in those microcosms in your community.
It looks like a variant of the fight between the liberals and the conservatives. But this person says, ask him for me, please. Why are people who are qualified saying that because the vaccines only have emergency approval, they should not be trying to give it to everyone in case there is an issue or worse, a deadly fallout? You did refer to this as an earlier question, but I think it should come back to you because some people who are now with us might not have been there earlier. And in addition,
Right.
I just wanted to add this to it all. At the end of the day, these vaccines still do not have final approval from the FDA. They remain emergency use authorization. And that will remain a stumbling block in the eyes of people like the person who raised this question.
Yeah. And again, it's a matter of your understanding of what is going on. The thought is that because the vaccines haven't been fully approved, something must be wrong. Let me back up a little bit. One of the great things about vaccines is that they're very much predictable in terms of long-term effects. Most people probably don't realize that. Everything that we give in a vaccine is degradable by the body. In fact, In order for the body to make an immune response, it has to degrade what it gets. It has to break it down. So within a couple of weeks of you getting any one of these vaccines, you will find no trace of it. When the FDA went back, and I think the European Vaccine Agency also did the same thing. When they went back and looked at the past 100 years of approving vaccines, they were not able to find a single case where there was any effects from a vaccine after 2 months had passed. There's a reason for that, because you don't have anything left in you from the vaccine.
Right.
Vaccine is like, have you ever watched Mission Impossible? This message will self-destruct in the old one. This message will self-destruct in 5 seconds. With the vaccines, the vaccinate will self-destruct within less than 2 weeks. So whether it is the AstraZeneca vaccine, whether it's the Sinopharm vaccine, whether it's these mRNA vaccines, both the mRNA and the product that it makes, both the proteins that are made by the AstraZeneca vaccine and the vector, the viral vector, will die within a prescribed period of time. So when people say we don't know if they're going to be long-term side effects, we actually do know that they won't be long-term side effects, because there's nothing left in your system to cause a side effect. You break it down and you pass it out. That's just the way proteins work. Proteins have a half-life. They don't sit around forever. We know what that is. So the probability that you're going to have any situation that will come up after that will cause you to say, look back and say, oh, I wish we had waited. That's not going to happen. Now, here's where emergency use authorization comes in. The emergency use authorization went through the same process, the same rigorous process, as if you were going to do full approval. So you might ask the question, why is it that these vaccines are still under emergency use authorization? There's a reason for that. The FDA actually has a process. And the process is that the FDA requires at least 6 months of data and review of the manufacturing process, inspections, site inspections of every aspect of vaccine manufacturing in order to give full approval. That is what the FDA is in the process of doing now. They've gotten the 6 months of data from most of these vaccine companies. And what they're doing now, they have to set up schedules to go into these manufacturing plants. In fact, Pfizer actually went ahead and preempted that by giving a video walkthrough of their entire process. The FDA, though, has to go in and do its own work of evaluating that, because those are the standards that have been set up by the FDA. The same thing for the WHO. The WHO has a rigorous process that they look at. The same thing for the EU agencies and the British agencies. They have a rigorous process, and it's time dependent. So that is why we haven't had full vaccine approval. Now, let me say something to you. For people who are vaccine hesitant and are saying, I need to wait over that period of time, I think we need to have a frank conversation with those individuals. For people who are truly anti-vax, this is just another argument they make. They really don't care. If full approval come, they'll just say, oh, it's all a conspiracy anyway.
Right. We have a few. Go ahead, Mr. Ellis.
There was one question as a follow-up to this, because Dr. Webley says the vaccine doesn't last in your body very long, and for that reason you're able to say whether there are side effects or not. The question here is, and how long will it take us before we need a booster?
Yeah, that we don't know. I think it all depends on what the next variant is. And I think it all depends on the immune strength of an individual. So, Mr. Ellis, for a 30-year-old, they might not need a booster ever. But for a 65-year-old whose immune system is in the waning days of their lives and have underlying conditions, they might need a booster. In other words, every single person, I think what they have to do now is that, and those studies are on the way, What they have to look now, they have to collect the data for breakthrough infections. That's why that data is being collected. And they have to look at breakthrough infections and determine who are the people who are getting breakthrough infections. And the data that I just saw, the vast majority of people is over 60 years old. So what that says to me is that people over 60 years old, their immune system is, their immunity to the vaccine is waning over time, which is not unexpected. Many vaccines, it doesn't mean that the vaccine doesn't work. It just means that that's the way your immune system works. It doesn't hold on to those immune proteins over time if it's not getting stimulated. And so what they've shown is that if you get a third dose of any one of these vaccines, it significantly increases the numbers of circulating antibodies, which are the immune proteins that bind to and neutralize the virus in your system. And that it actually boosts the number of memory cells that you have in the bone marrow and in the lymph nodes. So in my opinion, yes, legitimately, there will be people who need a booster. We knew that from studies that were done with transplant patients, for example, where with 2 doses of any one of these vaccines, they never even had a response. They got the 3rd dose and then they had a response, right? And so those are studies that will need to be done. What I'm wary of are vaccine companies coming and saying, oh, everybody needs a 3rd shot. Because yes, it gets them more money, but it doesn't necessarily mean that people need a 3rd shot. What I haven't seen and what I've been looking at the data of healthcare workers because they were the first to get vaccinated. You know, my wife, for example, as a nurse practitioner, got vaccinated last December, right? And so you're looking at that group of people who got their first shot in early to mid-December and early January. You're starting to ask, are the breakthrough infections more common in those individuals?
Right.
Than it is in people who got vaccinated in the last two months, for example. We're not seeing that whole scale, right? So what it says is that immunity is not waning in the vast majority of individuals. However, there's no doubt that immunity might be waning in individuals who have less strong immune system for whatever reason. And those individuals, they should seriously look at and determine whether or not they need a booster.
Dr. Webley, we have a question here from the message board.
Yeah.
And they say, I take the points of the docs and I agree with being vaccinated, especially if it relates to the variants. However, vaccines have only been approved by the FDA and WHO for emergency use, so they should not be mandatory. Can someone address this concern?
Again, this is kind of a twist on the information.
Right.
Because this statement suggests that there's something to be found out about the vaccines that we don't know.
Right.
And the FDA is waiting on that to give full approval. What I just explained to you is that that's not actually the case. If the FDA sees that anything is wrong with the vaccine, or if they're waiting on any data to be able to approve the vaccine, they would never have given approval, right? In fact, we now have billions of people worldwide who have been vaccinated. That is your clinical trial right there.
Right. Absolutely.
Right. And so, essentially then, I don't believe, I'm not one to go for vaccine mandates. So even though I'm a strong vaccine proponent, because I've seen how vaccines have saved lives over, hundreds of years, I would rather people not be forced to take a vaccine. Because for me, a vaccine is a medication. And if I can refuse to take a cancer drug, I should be able to refuse to take a vaccine. However, if you're not going to take a vaccine, it shouldn't be because of fear. It shouldn't be because you're getting misinformation. You should go out there and get the correct information. And then with that correct information, make the decision as to whether or not you want to get vaccinated. Weigh the risk versus the reward from an informed perspective, not from a perspective where you're swallowing all of what the anti-vax movement is throwing out there in very savvy ways, in savvy WhatsApp videos, because that's just going to make you end up exposing yourself. And that's my concern. I know people who have said, I understand how these vaccines work. They seem like they're good. I'm just not ready to take it yet. And I'm like, okay, that's the risk you're willing to take. That is fine. You have to assess your own situation. It's like a cancer patient who says, I don't want to take chemotherapy. I'm just gonna see what happens. I'm gonna wait and see.
Okay, we saw a caller just now attempting to call in. I think it was caller Judy. Do they want to try to call in again before we take another question from the message board or WhatsApp? Okay, while they attempt to call in, if they want to call in again, okay, I'm seeing another call in attempting to call in at this point in time. Caller, your life. Good evening, caller. I think they're having a bit of a difficulty getting on. I'll just continue to answer some of the questions from the message board. We know, for instance, that when this virus first surfaced, we heard a lot of persons who were elderly or persons who had comorbidities were the ones to be primarily afflicted by this disease, or considering that they were at increased risk of severe disease, hospitalization, and death. However, we're now starting to see, especially with the Delta variant, that some of the younger, healthier persons are now at risk. Is that
Mm-hmm.
as a result of persons being vaccinated and being protected? Do you think that this is a potential benefit? And is this a result of any of the trials that you've been seeing?
Yeah, I mean, I think, it's not surprising that you're seeing more and more younger people getting infected now, because most of the older people are protected by vaccines, right? They were targeted. The older folks were targeted initially. Nursing homes and the elderly were targeted for vaccination campaigns initially. Now with the Delta variant, it's more transmissible, and you have a higher viral load when it's transmitted, and so that is why some of these younger people are getting sicker. You're seeing more and more of them now in hospitals, meaning that they have severe symptoms. Because remember what I told you before, our immune systems are so good that we only get disease when our immune systems are what? Overwhelmed. When you have a higher viral load that is being transmitted to you, when you're in situations where there's more virus, you're going to inhale more of that virus for your initial infection, right? And so that higher viral load now, initial entry into your body, is what is going to leave you vulnerable to illness, even as a young person. So you might not end up dying, but you could be in the hospital, and be very uncomfortable for a while. And no, we haven't talked about long COVID, but that's another consideration, because people might say, okay, well, I get infected and I'm going to get better. Well, there's a thing called long COVID, where people who got infected with this virus, and after getting well, sometimes 2, 3, 4 months, 5 months later, they continue to have lingering symptoms of this disease. Everything from fatigue to not being able to think properly, you name it. There's a range of symptoms. We're seeing now post-COVID heart disease. The data shows that there is a significant increase in heart disease in people who have had COVID. And you can see it when you look at the data. Post-COVID diabetes, people who never had diabetes before, after having had COVID, turn up back at the hospital showing signs of diabetes. Why? Because the pancreas is one of those organs in the body that has a high level of ACE2 receptors. That's a protein that the virus binds to. It turns out that you're only born with a set number of beta cells. These are the cells that produce insulin, right? You're born with a set number of these beta cells. And COVID actually infect those beta cells. SARS-CoV-2 infect those beta cells and kill them. And after you have lost a certain number of those beta cells, then you can't effectively uptake glucose in the blood, and it shows up as diabetes. So post-COVID diabetes, these severe long COVID issues can turn around and be very detrimental to even people who are very healthy. We see that over and over again in case reports.
Right. We have a caller that finally she got on. This is caller Judy. Good evening and welcome, your life.
Hi, good evening, everyone.
Good evening.
Hi, Judy.
Thank you, Dr. Webley. I mean, this is a tremendous amount of information. And I think that's what I really want to address. Because for all of this trusted, accessible information that you're providing, there is just as much misinformation. And so I think the challenge here, and I would like your take on it, and even that of Mr. Ellis, though I know you're the keynote this evening. The language behind the science of immunization generally is inaccessible to us, honestly. And then where we look to public health officials, political authorities and the media for this information, I mean, quite frankly, the science behind this is just completely unfamiliar to media and the public. Some of the public health officials and political figures we look for information, and with social media, obviously, these efforts that are being put forward as you are and some others, I have to call it. There's a major assault in the social media sphere. So what can average citizens do to ensure that they are accessing reliable, trusted information that is truly of value to make these informed decisions about whether or not to take the vaccine?
Judy, you have hit the nail on the head. This has been a huge blind spot in science from millennia. When Judy, when I publish a paper from my lab, when I find something cool from my lab and publish it, it's not published so that the lay public can understand the information. That's not the format in which it's written. And it's not because I choose to write it that way. It's because that's the way I have to write it in order to get it published. There's a strict way to put the data and to send the data out there. And science has been communicated in this way for so long. And now we come to a crisis in a pandemic. And those of us who are used to reading research paper, for us, it's as clear as day. But as you rightly said, for the general public, it might as well be a foreign language. And so I think the role now of physicians, nurses, nurse practitioners, physician assistants, and public health experts is to take that dense science that you keep showing up in paper after paper after paper and interpret it for your people. And that's what I've tried to do over this pandemic. It hasn't always been easy. I have been attacked and attacked and attacked. And when that has happened, I've said to myself, well, people are not attacking me. They don't know me. They don't dislike me. They just don't agree with this information and the way I'm presenting it because they're not used to it. And I've struggled many times to break down the level of science that I typically communicate with my students, with my colleagues, to translate it into what the general public should get. It truly has been a failure of public health, and it has truly been a failure of the scientific community of huge proportions. And I think after this, we can't possibly, with good conscience, go back to publishing science in the way we used to. We have to find a better way to communicate science to the public, because science should be something that people can understand and speak about, because all around us, every single thing we look at, everything we do has some aspect of STEM in it, of science and technology and engineering and math. We should find a way to be able to communicate that. Mr. Ellis, go ahead. Yeah.
Hi, Dr. Webley and Judy. I think that's a very interesting question. I think part of what I am hearing, though, is a lack of trust. There is that undercurrent of a large section of the community also believing that so-called big pharma, the big pharmaceutical industry, is about to make another killing, that this is about creating the environment for an industry to make money. And if you move in with that particular perspective, then you are going to be distrustful of a lot of the information that has been put before us. And that's one part of it, Judy. The other part that I think we need to look at is, look, we are now in an era where Dr. Webley could be in Massachusetts. He could be in Denmark. The experts are all over the world.
Mm-hmm.
What we are struggling to do often is to look inward to find an expert to talk about this issue. Yes, they may have expertise, but there may be somebody else outside of the country who is better able to speak to the matter. We are focused on our politicians and our public health officials almost exclusively. And that is part of what perhaps needs to be changed. We need to have a bit more of the information coming from the scientists, wherever they are in Barbados, the Caribbean, and the world. If we can do that more regularly, I believe we will penetrate more people. But you cannot rely exclusively on politicians to convince people on scientific matters. It's not going to work. All right. They can take you so far, but you need the scientists to take you further. That's my judgment.
Yeah, I think that has been a part of the problem too, Mr. Ellis, that politicians have been the ones giving the message, and that shouldn't be so. Your public health department should be apolitical, because that is the first rule of public health. That people need, you have to have that good communication where people can trust what you're saying. I think, to Judy, we can't discount the fact that we're living in an era where it's so much more easy to disseminate information that's not true. And people are getting it from all sorts of platforms, and they just don't know how to parse it. They don't have the background to be able to say what is true and what isn't. When I got trained as a PhD in microbiology, one of the first things you get trained into is, where are the sources of good information? Where are the sources of trusted information? Where are the databases that you can go and that if you pull something, it was properly peer reviewed, and you can go and trace that all the way back to who reviewed it in the journal. That's one of the first things you're taught. And over the years, you hone that. So for me, when I'm digging through information, it's not hard. But what I've seen is that a lot of people have walked past tons and tons and tons of true information to dig out misinformation that they want to believe. And you're right, Mr. Ellis, that people don't trust vaccine companies, and probably rightly so, that they're thinking that people are looking for money. But who wants to do anything without being paid? The truth is, these companies would rather make any product than vaccine. Vaccines are some of the cheapest products you can make. Yes, if you're giving it to billions of people, you're going to make a killing. But a company would rather make a cancer drug that you can sell for hundreds of thousands of dollars for a treatment course, rather than make a vaccine that you're selling for 30 or 20 or 10 or $5 a pop. Moreover, with these vaccines, most individuals are not paying for vaccines. The government is paying for it. And so, they're not taking money from the public, so to speak, out of your own pocket as now, yes, through your taxes. So, there are a lot of caveats to that thinking. That you can't trust these companies because they're making the vaccines. These are the same companies that make the antibiotics that you've been taking, by the way.
We have another question here from WhatsApp. What is the general attitude towards taking the vaccine internationally? Are educational programs effective in terms of encouraging persons to take the vaccine? Or is there a need for greater community effort by civic organizations to reduce reluctance to take that vaccine? And should essential services lead in the way of encouraging vaccine uptake?
Yeah, I mean, in the first phase of doling out these vaccines, in most places, the people who were anxious to get the vaccine went and got it. Now you're in the phase where people either just can't be bothered, they're hesitant. And so I think the vaccine needs to go to the people. You need to go to the local barbershop and the local hair salon and have a trusted community person or a trusted expert talk to people in small groups about the vaccine. Answer their questions the way you're doing here on this platform. Sit there and answer. I've done presentations where I sat there for 3 hours and answered every question that was asked of me. The ones I couldn't answer that I didn't know the answer to, I told them I didn't, or I give them literature that they could go and get the answer. But I think those things need to happen. And for me, when I've sat with two people for 2 hours and answered their questions about the vaccine and about what I think about the safety profile and what the side effects are and about the virus and what I expect to happen based on my area of expertise, until I answered all of their questions. If you want people to be safe in your country, in your community, our health experts and our public health people have to be willing to do that. You have to be willing to go where the people are to talk with them about this, because people have real hesitancy. People have real reasons to be hesitant. Many times they have real reasons to be distrustful of government in several situations, because we've seen over and over again that we've been deceived. So now it's going to take time for some people to come back to the place where they say, okay, I'll take these vaccines. I give you an example. Our university is mandating that everybody who's coming back, every student who's coming back in September in a few weeks, need to be vaccinated. Every student. Moreover, for our football team, all of them need to be vaccinated. And those who don't choose to get the vaccine, they will be off the team. Now, it might just seem like a sport, but a lot of these students, especially our Black students, use sports to get them through college. It pays their tuition. It gives them a stipend. So somebody's, professional career, even if it's not going to be in football, it could be terminated because of not getting vaccinated. And again, I'm not one for mandates. But when I heard this, and when these players asked me to come and speak with them, I went. And for the two holdouts that they had, I sat with them and answered their questions. And they were intelligent, in-depth, serious questions that they had. Many of them, because they had heard the anti-vax rhetoric, they have seen so many videos, they didn't even realize how much of those they had watched and the impact it had had on them. And I sat there and I talked with them the way I would talk with my own kid. And I answered their questions in a respectful way. And I didn't disparage them. I didn't discount their lack of belief in these vaccines. I helped them to understand the science behind it. And when I did, I said to them, you don't need to walk out of here today saying that you're going to get the vaccine. Think about what I've said to you. Look at the slides that I've shared with you. And if you have further questions, come back and talk with me. And both of those young men end up getting their vaccine and staying on the team. I tell you that story to say that sometimes it's not big crowds of people that you're going to talk to that's going to convince people. You have to be patient enough to talk with people and be willing to answer every question they have until that fear goes away or is diminished enough that they feel safe to go and take these vaccines.
Okay, we have another question from the message board. Dr. Webley, can you explain why just achieving herd immunity with no reliance on simply vaccines is not feasible for COVID-19?
It's not feasible for any disease. We've never had any disease for which we have reached herd immunity without vaccination. And can you imagine if we decided that, okay, let's not make a vaccine against something as severe as SARS-CoV-2 infection, and let's just wait for people to get infected? Ask yourself this. How many people would you be willing to let die? How many grandmothers and grandfathers and senior citizens and young kids who are vulnerable are you willing to have die so that you could have the vast majority, you're talking about 80 to 85% of people in your country infected, or in the world infected? Right now, We've seen the statistics. You've seen how many people SARS-CoV-2 has killed over the world overall, and how many people have been confirmed to be infected. Now imagine that every single one of the 7 billion people in the world would be exposed, with the potential that 85% of them would get infected. How many deaths would one have? So, for me, there'll be no equivalence there. It'll be an easy decision for me to make. And so herd immunity is reaching a place where enough people have been vaccinated. And if you notice, I didn't say infected, have been vaccinated, so that you have the vulnerable people can be protected. And why did I say vaccinated as opposed to infected? And somebody had asked a question in the chat earlier that we didn't address. If you have already gotten infected with the virus, why do you need to take a vaccine? There's a good reason for that. When you get infected with the virus, as I mentioned in passing, what the immune system see is not one viral particle, that round cartoon that you see on TV. What the immune system sees is equivalent to looking at a 10-story building, where it's reading every window, every door, every ledge, every beam, every balcony, and it's making an immune response to each of those entities. Now, here's the trick with that. And that is why many, many people who have gotten infected before got infected again and died, right? Especially with the new variants. Why? Because while the immune system is busy reading and making a response to the windows and the ledges and the doors on the third floor and, the antenna on the roof, what it really needed to focus on is the front door, which is a spike protein, because that is what the virus needs in order to get in. If it can't get in, it can't make any of those other components that it needs. What the vaccines have done is that instead of having the body make a response against those 30 proteins, it's a large virus. It has 30 proteins, and each of those proteins have multiple hundreds of discrete protein stretches that the immune system is going to make a discrete response against. See, that's how complicated the immune system is. Instead of having the immune system focus on all of that, it makes it focusing on the front door, the spike protein. That's what the virus needs to get in. Let's make a response, a very high response against the front door. Let's fortify the front door, because it's not going to get into the house via the balcony, via the roof, via these other things. It needs to get in via the spike protein. And so when you get one of these vaccines, the body has made a ton of response to that spike protein, and that spike protein get neutralized. In other words, it's like this virus uses the spike protein as the key to open your cell to get in. And what you've just done with the key is that you've shown the body what the key looks like. And what the body has just done, it has taken a piece of duct tape and wrap it all around the key, so it can't fit into the keyhole anymore. Now, you could go and try to wrap duct tape around all of the other proteins that the virus have, but it would make no difference, because it needs that key to get in. And so that is why the vaccines work so very well against all of these variants that we've seen, is that it drives such a strong response against them.
Okay, we have another question here coming in on the message board. Does it make a difference if the vaccine is administered with or without gloves?
It would only make a difference in terms of whether or not the person's hands are clean.
Right.
You wear a glove when you're doing any sort of medical procedure on a person, because if you're going to pierce the skin at the site of the needle entry, if you have microbes on your hands that are unwashed or something like that, as the person administering the vaccine, you could actually introduce them into the arm of somebody. But if you've washed your hands, there's some nurses who prefer not to wear a glove when they're doing vaccines. If their hands are clean, if they've washed their hands and they're sanitized, it should be just as effective. It won't affect the immune response, but you could imagine getting an infection at the injection site. That could leave you with a nasty scar and something, you have microbes on your skin that are just ready for your skin to break so that it can get in. So that would be the only danger there. But, a healthcare facility would mandate what it wants its healthcare workers to do. And most healthcare facilities would say, I want all of our nurses, or whoever is administering a vaccine, to wear a pair of gloves.
Dr. Webley, this question of the uncertainty as to how long this vaccine lasts and protects an individual is, to my mind, a most important one. Because if we are saying to people, you need to be vaccinated because we are striving for herd immunity as a result of a certain percentage of the population being vaccinated, it becomes important for us to have some idea as to how long this thing will last in your body. And to me, that is a very significant uncertainty.
Yeah, for me, it's not. I think it's neither here nor there how long it will last.
Why?
Let's say it lasts 6 months.
Mm-hmm.
Well, you're protected for 6 months, right? You're protected for 6 months. And after that 6 months, you get another shot and you're protected again. Many of us, when we go to the doctors and we get an antibiotic, we don't just take one dose. We take pill after pill after pill until it's gone. So the time period that the immunity lasts is not an indictment on the effectiveness of the vaccine.
No,
The
the vaccine is
effectiveness of the
effective.
vaccine is its ability to prevent infection when you actually have that immunity. And if they get information that says that immunity wanes, then they can come back with a booster and boost. Because if you got one
But,
shot, you shouldn't have a problem getting the next one.
but they are uncertain. They can't tell you when you will need the booster. Look, up to
Why
today,
can't they tell you? Why can't they tell you?
well, can you tell me how long?
No,
Let's
I'm
say
saying, why can't we tell you?
because I am unaware. Up to that was the issue that was raised earlier in the
Yeah, we
conversation.
can't tell you because not enough time has passed, right?
Okay,
This is a pandemic that is just a year old. I know it feels way longer, but it has been
understood.
going on for more than a year and a half, and that is why they can't tell you. But my point
Understood.
is, yes, but for me, it doesn't matter to me how long that immunity will last. I just want to know that at this point, I am protected. And if
But
I realize that I'm not protected, I want to get another shot so I can be protected again,
let me
so
ask
that,
you.
we don't have that issue. Yes.
I checked nature.com today, and
Hmm.
nature.com has Israel going into a third booster. Why would they be doing that? They were among the most successful when it came to vaccinating people. Why is it that they would be moving to that level so quickly?
I think they're looking at the data that they're having on the ground. I have to assume that that's what they're doing. They've been talking about it for a while now, that they're going to be giving booster shots to certain parts of their population. They're not giving it to everybody right now. They're looking at, and they haven't started giving it. They're looking to do it. And I would say if the data shows that, like what they're seeing in Israel, that they're going to need a booster shot after 8 months. I've seen the 6 month data, and the 6 month data on the vaccines, on all of the vaccines that I've seen, including the AstraZeneca vaccine, said that you don't need a boost, right? It says that you're still protected. I think it drops by about 6% efficacy over that 6 month period. So, in my opinion, the vaccine efficacy. Moreover, remember also that all that is being measured is antibody response. The immune system is way more than antibodies. We have not seen any data on the T cell response and the
Mm-hmm.
memory T cell response. And for
Right.
sure, the T cells are playing an important role. And that is why I say my marker for when people will need boosters is when the people who were initially vaccinated start showing signs that they're having more breakthrough infections than the rest of the population. That for me would say that you're waning. Because what Israel has not done is that it hasn't gone around and sampled the people who have been vaccinated to
Correct.
see what level of vaccine efficacy they have. And that is the criticism that Israel has faced for doing this, right? They have not shown any data that says that they have proven that people's immunity is waned. What they've seen is what we've seen everywhere, where the older people who have been vaccinated, some of them have had waning immunity. Always was going to be expected, because the older you get, the less effective your immune system is at taking a boost for anything you're going to vaccinate against. So I'm not saying that Israel is doing something wrong. Of course, giving another boost if you have the vaccines. But in my opinion, those extra doses of those vaccines would have been better sent to countries who have no vaccinations at this point, rather than giving a third boost to people who probably don't need it.
Given to the Palestinians.
Exactly.
Dr. Webley,
Yes.
I just wanted to highlight, because I know a lot of persons are all caught up on booster doses, but booster doses for lots of conditions, it's not something new. We have booster doses for Hib and Hep B that we give children as part of the vaccination program here in Barbados. There are some persons that we know, especially for instance with the hepatitis shot, that even after having their 3 established doses, sometimes may not have mounted a sufficient response, and so they go on to get what we call a booster dose.
It's how soon, though.
Right, but how important really is it for us to necessarily focus on the taking of that booster dose, and is the implementation of an efficacy study within your local population important?
Absolutely. Anytime you're going to do any sort of widespread giving of medication, you have to have a way of assessing effectiveness. In my opinion, though, Dr. Grandison, it is of no effect for people who have had no vaccine to worry about when they need a booster.
Right.
If you have had no dose of a vaccine, why are you worried about a booster?
Absolutely.
It doesn't affect you either way. What you need to think about is, can I get my first shot after you've gotten your first 2 shots? Because the second shot that you got of the vaccine, by the way, is a booster.
Absolutely.
Right? That's what that second shot in 3 weeks is. It's called a booster. Right? It does exactly what you want it to do. It boosts the immune system. So, for me, I would worry about getting that first shot and then say, okay, when is it that these first shots are going to wear off? I would be concerned about that.
Right.
If I see people around me having that first vaccination actually waning and wearing off, I'll be like, whoa, I probably need a booster. Why is it that they're not talking about a booster? Pfizer is the first one that came out and talked about people needing a booster with 0 data. And I was very upset when I saw that. I posted on it on Twitter, and I'm like, this is bordering on being unethical. You have 0 data showing that people need a booster. If you start showing me the data that says that people need a booster, then I'll say, okay, you can make the booster. Nobody is concerned about it. Go ahead and make the booster. But don't come out saying that you're going to look for approval for a third shot of the vaccine when there's been no evidence that says that you need
what
one
was their
at this point
what
in
was
time.
what was their rationale for that?
Their rationale was that they are assuming, based on historic evidence around coronaviruses, historically, coronaviruses are notorious for having waning immunity when you get infected with them. That's why the original coronaviruses that were discovered in the 1960s, the cold viruses, and even the SARS, the original SARS virus, immunity didn't last very long for people who got infected and recovered. It lasted for a year, I think, in most cases. So I think they're probably using that historical data. But you see, nobody was vaccinated. Vaccines give you a high amount of the thing that sends your immune response into high gear. And I think I need to see the half-life of that. I need to see what is happening after 6 months, after 8 months, after a year, before I start jumping on the bandwagon and say, oh, everybody needs a booster now. Because number one, a booster costs money. It takes time. It takes a whole set of resources to give a booster. So it's not an insignificant thing.
Right. Dr. Webley, another question coming in. We know that, for instance, I'll pause my question because we have another listener who has just joined us live. Caller, you're live. Go ahead, answer your question.
Yes, I want to go back to the question of vaccine mandate. And while I agree that the mandate might not be something that is desired. In situations where governments worldwide are the ones bearing the cost of these vaccines, and hence individuals are getting the vaccines free,
Mhm.
where governments now have to protect their populations, individual business owners have to protect their businesses, who then should bear the cost of ensuring that a workplace is safe, that a community is safe? In circumstances where people don't want to get vaccinated, additional testing will then have to be done to ensure that people are clean of this virus. Who should bear that cost,
Yeah,
ideally?
you know, that's a very good question. While I don't believe in a government mandate for a vaccine, I'm not opposed to a local business saying, hey, or a hospital saying, hey, if you're not vaccinated, you can't work here. You know, here in the United States, the hospitals that surround me, every healthcare worker has to get the flu shot every year, unless there's a special reason why they shouldn't get it. Otherwise, they can't work there. So I believe in that. So if a certain person wants to exercise their right not to get vaccinated, they should also be willing to accept the responsibility of being asked not to work at a certain place if they decide not to get vaccinated. That's how these things work, right? But I think when it gets to the place where the government now mandates that you get a vaccine, it takes it to a totally different level. And I think maybe I'm looking back historically of when the smallpox vaccine was mandated,
Yeah.
and the anti-vax sentiments against it increased dramatically, and hesitancy and conspiracies were significantly increased, and they reached a place where they had to pull back that mandate. So, in my opinion, we've walked that road before, where it has been mandated and it didn't work out in the way we thought it was, and smallpox was not eradicated under people being mandated to take it. It was eradicated after that mandate was lifted and specific public health measures were put in place with groups of individuals like Larry and other people going around the world, going into parts of India where there was low vaccination rates, going into parts of Africa and just vaccinating. Because you see, we live in a global community, and we like to say it. A pandemic really shows you what a global community looked like.
Yeah.
Until this pandemic is eradicated in every corner of the earth, until it is under control in every country, on every continent, none of us, wherever we are, will be safe. The longer we take to get it under control, because I don't think we'll ever fully get rid of it. It likes us too much to leave us alone. And viruses depend
On
on
us.
people
Mm-hmm.
to be transmitted and to stay in the population. As long as you have one person who has decided not to protect themselves, not to wear a mask, not to heed the guidelines to stay away from large public settings and large gatherings, these viruses will be transmitted. They also depend to some extent on our desire to absorb and regurgitate misinformation. Because the more of that's passed around, is the more this virus gets transmitted, the more people
Right.
remain vulnerable. And so we have to realize the role that we play. Without us, this virus is stopped dead in its tracks.
Mm-hmm. Mm-hmm.
The things that we
Well,
love, gathering together, being with our friends, hanging out, being at a party, is exactly our vulnerable spot for this virus. And the only way we can protect ourselves is to do these public health measures. And vaccine plays a huge part of that.
well, we really are faced with a dilemma, and the question which has been posed by the caller is one that we have to encounter on a regular basis. One of the issues that we face here and now in Barbados is that we need to get more vaccines of a different brand. Because if you have only one type, there are people who will have their reservations about one, sometimes more than the other. And the question is, are you going to coerce people to go and
Mhm.
take that which they may be uncomfortable with? And that's where the studies and the analysis must take place. Um, it's a very tough choice to ask a person to go and put something into their body that they are grossly uncomfortable with and uncertain about.
That is certainly true, and I think it's a matter of understanding as well. Right now, we have vaccines out there on 3 or 4 different platforms. You have the mRNA vaccines, you have the viral vector vaccines, you have this inactivated vaccine, the Novavax protein vaccine, and the Vector Institute protein vaccine in Russia is being used right now. And so you have vaccines on 4 different platforms right now that are out there. However, again, we see where the inequity in the world has caught up with us again.
Yeah.
In 2009, when we had the influenza, the H1N1 outbreak, we saw that inequity at its best, where the rich countries bought up every dose of those vaccines, leaving the poorer countries to die from this virus. And the World Health Organization and others said this will never happen again. Let's prepare. Let's put together something. And COVAX came out of that. And the thought was, with COVAX in place, with this combined buying power of this organization, that would never happen again. But we've seen it happen. We've seen it happen again with this pandemic, where yes, there is vaccine hesitancy, but there are lots of places in the world where people want these vaccines and can't get them. And in the US, we have them expiring in the millions of doses and being thrown away. For me, this is egregious, and something has to be done about this health inequity across our planet.
Mm-hmm.
Because in the case of a pandemic like this, that with a virus that is so contagious, we talk about Delta. At least, yeah, I was saying that I find it very troubling that we're seeing 2009 repeat itself again with the inequity, the health inequity, where the distribution of vaccines and is concerned. And yes, there are people various places who are not ready to take the vaccine, but there are lots of people who want to get a vaccine in many parts of the world and can't get one. And at the same time, you have places where vaccines are expiring and being thrown out. For me, that is just a very troubling health inequity around the world at this time of this very contagious virus. And I just want to end that by saying, until this virus is controlled everywhere, none of us can be safe. And I'm concerned about Delta, like everybody else. I'm more concerned about the next variant that could pop up that we haven't heard anything about, that we know nothing about, that is going to take a while for us to figure out. And we just don't know if even the vaccines that we have now will hold up against it. That is my worry, because as the pandemic continues, all it needs is just replication. The virus continues to replicate. There is a probability that you could have a variant that pop up that is better than the one before it. That's what these viruses do.
Look,
They don't mean to kill us. They don't mean to maim us. All they want is just to make more of themselves, but they will do it at the expense of your life if they have to.
I think we got in the closing stages. So can Dr. Grandison?
Yeah, I just want to ask 2 questions with the permission of Dr. Webley. One I've had here as a WhatsApp message, and then I'll ask my closing question. The first question is, what are your thoughts on incentivizing vaccinations? And I personally wanted you to explain the importance of genomic surveillance in your population.
Yeah, so I would never have thought 5 years ago that you would need to incentivize people to take a vaccine for something that's going to save their lives. But, I've seen over and over again that it has increased vaccine uptake. Just recently, here in the US, the president has asked states to give people $100 for taking a vaccine. So they give them $50 when they come for the first shot, and next $50 when they come for the second shot for the mRNA vaccines, and they get $100 for taking the Johnson and Johnson vaccine. I guess at this stage, these are unprecedented times, and it calls for unprecedented strategy. We might be setting ourselves up here, that for every time something like this happens and you need people to take a therapeutic, you might have to pay them to do so. So be it, if this helps to stop the vaccine. You asked about genomic surveillance. I'm not sure what you mean by that. Can you explain a little bit more when you said genomic surveillance in the population?
In terms of you performing genomic, genotyping, really,
Of the
especially
virus.
of the virus. So, for instance, if
Yeah.
if you have some persons who are coming in that are positive, yes, you may want to just randomly test some of those, but especially in a setting where you may notice a particular pattern in clinical presentation. What really is the importance of sampling that unique population to see if there's even something new that you may
I
have?
think it's indispensable. It is absolutely indispensable. We keep saying that these variants are popping up in places like Africa and India, and in the UK. And the truth is that the reason why they catch it is because they're testing for it. They're testing at a rate of somewhere around 10% of samples that they're taking. And especially if it's coming from somebody who's been vaccinated. And as you said, if you're seeing differences in severity of disease, in presentation of certain symptoms, it should absolutely be sequenced. And I think this is a great opportunity for biotech institutes, for universities. The University of the West Indies, for example, there in Barbados. I think this is a great time to apply for a grant, to get a sequencer and or to utilize the sequencers that they have there for biomedical research, to increase their capacity to run through the sequences of these viruses, get the expertise, get people trained in it. Because the more you know, it's the better for you. If you know that you have Delta there and it's spreading at a certain rate in a certain part of the population, you can trap that and you can mitigate, you can give up-to-date information to your people, because sequencing is not hard anymore. It doesn't take very long. It doesn't take a lot of resources. It just takes the expertise. So I firmly believe in that. That's something that's being done here now, way more than it was done at the initial stage of the pandemic. We weren't doing sequencing in the US at even half the rate that they were doing in the UK. The UK is a master of sequencing. The rest of the world is catching up to a great extent, but it's indispensable. It's necessary.
Mr. Ellis?
Yes, well, I want to thank you very much for inviting me into this discussion because, as I said, I agree that we need to reach beyond Barbados for as much of the expertise that we can find. Dr. Webley, one of the observations you made was about the inequality with respect to the drugs. And you know that that's symbolic of so much more that exists between the rich and the poor. And the real
Absolutely.
question is, to what extent can COVID demonstrate to all of us the fact that we are still one global village, that a disease that breaks out in China touches the whole world, and that a Delta variant that begins in India touches all of us. And that should
Exactly.
speak volumes about how we need to reorder things. So thank you very much. I really appreciated the exchange, and I want to, I'm very happy to have participated in it, Dr. Grandison.
Well, thank you
Thank you
so
so
much.
much.
Thank you
Thank you
so
so
much.
much, Mr. Ellis, for your questions. It was really good being on this platform with you. You're definitely knowledgeable about what is going on, and I think it's going to take people like you, with your experience in journalism, with your desire to ask the right questions and to probe them for the truth. I think people like you are also indispensable to this fight.
Thank you very
Well,
much.
well, thank you so much, Dr. Webley, and thank you, Mr. Ellis, for coming on the show and really encouraging a very robust discussion around vaccinations. I can see that we still have so many questions. I have encouraged persons, if they want to, they can post their questions on the Instagram page. That's Cornerstone Med _246. And we'll try to get your questions answered. Thank you so much, Dr. Webley. Once again, I also want to thank my listeners who would have either called in, post a question on the message board, or even send me a WhatsApp. I just want to encourage you to follow us on both Podbean and Anchor, and join us next week on First Aid Chats by Dr. G, Closing the Gap. Thank you so much, gentlemen.
You're most welcome.
Thank you for having me, Dr. Grandson. Appreciate it.